All right, today we're going to start with lesson 7.4, scientific notation. So we're going to learn how to express numbers in scientific notation, and we're going to find products and quotients of numbers that are expressed in scientific notation. So we're going to multiply and divide those suckers. First, some rules. A number expressed in scientific notation takes the form of a times 10 to the nth. And here are the rules. A has to be greater than or equal to 1 and less than 10. Basically what that's doing is telling us where we're going to place a decimal point, which will make more sense here in a minute. N has to be an integer. It's either it's like a counting number 1, 2, 3, 4, or it's a negative counting number, -1, -2. It can't have decimals or fractions in the exponent. So here are the steps, and we're going to observe these steps pretty closely on the first couple of examples and then see if maybe there's a way to kind of shortcut a couple of steps, but I want to make sure that the steps make sense to you as we're going through with what's going on as we convert numbers into scientific notation. Basically, a scientific notation is a way to take numbers that are really, really big, like millions, billions, and trillions, and kind of shrink them down so that they're not so big and scary to work with, or to take numbers that are super duper small, like 0.000000, you know, and where they've got a bunch of decimal places to take up, and make it so that they're easy to work with. So here's what it's going to look like. We've got a really big number. This is 201 million, right? And we want to express this in scientific notation. So when you look at your notes, you've got step 1. We're going to move the decimal point until it is to the right of the first non-zero digit. So this is the first non-zero digit, right? So we're going to put a decimal point right behind that. So 2.01, and then you'd have all those zeros. Now step 2 is take note of the number of places that we moved. How many places did we move that decimal? Well, you just count them up. The decimal was here, right? And now it's here. So how many places did we move it? That's 1, 2, 3, 4, 5, 6, 7, 8. So our exponent, and that's the number n when you look back at that formula, right? N was 8. Since we moved it to the left, we moved the decimal to the left, that 8 needs to be a positive 8. Okay? Then we would write, step 3 tells us that we would write all of this out in scientific notation, and this is where we're going to use a shortcut later, because I don't necessarily like all these zeros that keep making us write. It would look like this, times 10 to the 8th. And then step 4 is just clean it up, and we're going to jump to that step a little sooner here in a second. But so this is the original number that we started with, but we moved the decimal point here. Now we're just going to write it without all those unnecessary zeros in it. 2.01 times 10 to the 8th. Okay? So really all we did was move a decimal point 8 times, and then slap a times 10 to the 8th on the end of it, right? It's really basically that simple.
So that's the answer.
It's 2.01 times 10 to the 8th is 201 million in scientific notation. And we actually kind of use forms of scientific notation more often than you think. Like, if you ever hear people talk about, like, that baseball player gets paid $1.5 million. That's basically scientific notation in shorthand, because a million is 1, 2, 3, 4, 5, 6, 7. 10 to the 7th is a million. And so when you say they get paid 1.5 million, what you're really saying is they get paid 1.5 times 10 to the 7th. 10 to the 7th is a million, okay? So we talk in scientific notation a lot. We also can make scientific notation work for numbers that are super small, like this. So we want to follow the same rules. Step 1 was to take the decimal point and move it to the right of the first non-zero digit. So the first non-zero digit there is 5, so we're going to write it as 5.1. So how many digits did we move the decimal? 1, 2, 3, 4, 5. We moved it 5 times. And so times 10 to the negative fifth. That's a 10. I don't know why it looks like 16. All right. I mean, we just shortcutted all 4 steps there into one step, pretty much. Does that work? Okay. Let's try a couple more examples. This is 68,700,000,000. That's a mouthful. So we're going to shorten that to, where do we put the decimal? We always want 1 digit in front of the decimal. So between the 6 and the 8, we're going to write 6.87. And then how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th. Where do we want the decimal to be here? Between what 2 numbers?
7 and 2.
Between 7 and 2. I want 1 digit in front of the decimal. So 7.25. How many places did I move it? 1, 2, 3, 4, 5, 6. 6, right? 1, 2, 3, 4, 5, 6. So times 10 to the negative 6th. If the number's super small, we want a negative exponent. And by yesterday when we were doing negative exponents, or back in a lesson or two, we talked about we don't ever want negative exponents, right? Scientific notation is kind of that exception. We want negative exponents here because we want to indicate that this is a super small number. And we know that a negative exponent moves it to the bottom of the fraction, right? And when you get a really big number on the bottom of a fraction, that means the number is really, really tiny. So that's what we're doing here. All right. We also can take numbers that are written in scientific notation and move those into standard form. And so, again, they give you some steps here that you can follow. If n is greater than 0, that's if it's positive, move the decimal point to the right. If the exponent is less than 0, move the decimal point to the left. Okay? And then we insert zeros and decimal points where they need to go to make that number work. So, all I have to do, 6.32 times 10 to the 9th, isn't that? I can't read it. Times 10 to the 9th. Okay. So we're going to write 6, and then I want to move the decimal point how many times? 9 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty much with scientific notation, you just got to be able to count. And most of you can do that pretty well. All right, so 4 times 10 to the negative 7th. I want there to be a decimal point. And then I want to count 7 digits. 1, 2, 3, 4, 5, 6, 7. 4 is the 7th digit. All right. You'll get lots more practice on that on your assignment today. Well, a little more practice anyway. Now let's talk about multiplying. Multiplying numbers that are written in scientific notation. This is all multiplication here. 3.5 times 10 to the negative 3rd times 7 times 10 to the 5th. I can multiply in any order I want, right? What property is that?
Associative.
Commutative property. Okay? Commutative property lets me multiply things in any order that I want to. And so I can rearrange these a little bit. I can do 3.5 times 7. And I can do 10 to the negative 3rd times 10 to the 5th. Okay? What's 3.5 times 7? 24.5. And what's 10 to the negative 3rd times 10 to the 5th?
That's 10 to the 2nd.
10 to the 2nd. Remember, we add exponents. When we're multiplying bases, we add exponents. So negative 3 plus 5 is 10 to the 2nd. So this is times 10 to the 2nd. Now, am I done yet?
No,
What's wrong with this?
you can simplify that all the way.
What do you mean by simplified?
Like, you can solve it.
Well, I can write it, I do need to write it in standard form, which we'll do in a minute, but is this in scientific notation?
Yes.
Is it?
Wait, no,
What's wrong with it?
there has to be, you have to scoop the 24.5 over a.
Decimal point's not in the right place, is it? Because this number has to be between 1 and 10, doesn't it? Okay, so I need to move the decimal point over 1. So for now, if I move the decimal over 1, that would be 2.45 times what? Times 10 to the first, but then I've still got this times 10 to the second. So now I need to simplify it.
So
10 to the third. 2.45 times 10 to the third. This is the step here that to me is like where it has the potential to get a little bit confusing. But you just want to kind of ignore this 10 to the second for now and get this part into proper scientific notation and then simplify the exponents. Okay, so now I've got it written. This is scientific notation. That's proper. Now I want to write it in standard form. So let's change this to standard form. So it would be 2, and then I want to move the decimal how many times? 3 times. 1, 2, 3 times. So it's 2,450. Okay? Let's try another multiplication. 7.8 times 10 to the negative fourth squared.
You have to distribute first.
Yeah, everything gets the exponent, so it'd be 7.8 squared times 10 to the negative 8th. Now I just need to square this. What's 7.8 squared?
60.84.
60.84 times 10 to the negative 8th.
Decimal point over.
Got to move the decimal once here, so it's 6.084 times,
10 to the negative 9.
well, this would be times 10, right? Just to get this part simplified, and then we still have the 10 to the negative 8th. 10 to the negative 7th, because this is a positive 1 plus a negative 8. So it would be 6.084 times 10 to the negative 7th. So that is proper standard notation, or scientific notation. Now we want to write it in standard form. So we want a decimal, and then I want to move that decimal has to get moved 7 times. So 1, 2, 3, 4, 5, 6, 7, 0, 8, 4, 6, 0, 8, 4. Basically, the way that I think of this when I write the decimal, whatever number this is, if it's negative, I want 1 fewer zeros than that number. So if this is a negative 7, I want 6 zeros. If this was negative 8, I want 7 zeros. If this is negative 22, how many zeros? 21 zeros. Okay? So that's kind of the way I think of it. All right, so those were 2 multiplication problems. We can multiply. You just multiply the factors and multiply the simplify the scientific notation using the rules you already know, and simplify it in the end. All right. Division is going to be the same thing. I want to divide the 2 factors, and then use the rules for dividing the scientific notation that we've already used. So 3.066 divided by 7.3. 0.42. 0.42, and then 10 to the 8th divided by 10 to the 3rd times 10 to the 5th. Now let's simplify, or let's get this into proper scientific notation. 4.2 not times negative 10, 10 to the negative 1, because I moved it to the right 1 time, times 10 to the 5th, and then simplify the exponents. Times 10 to the 4th. All right, that is proper scientific notation. Now we can write it in standard form, which would be 4, and then I want to move the decimal 4 times. So 1, 2, 3, 4. 42,000. Alrighty, last slide. One more division problem. 2.3958 divided by 1.98. 1.21. 10 to the third divided by 10 to the eighth. 10 to the negative fifth. 3 minus 8 is negative 5. So that one doesn't, I mean, we're done with that as far as scientific notation goes. Now we just need to write it in standard form. So since I've got a negative 5, how many zeros do I want? 4. So it'd be 1, 2, 3, 4 zeros. 1, 2, 1. Okay?
Yep.
All right. I've got a practice worksheet for you.